Hello, welcome to the second video where I attempt to remedy this abomination in front of me. A few key things I want to say right off are that while watching, be very attentive to how sleepy I'm getting, and also please ensure this video gets posted in the VESCify media channel. Thank you, Nicole. Wait, I can ensure that it gets into the media channel. I'm a mom. Alright, anyway, enjoy the rest of the video, and I'll see you then. Goodbye. Alright. It is time to finish or continue working on this project. So, since last time, I have printed this little O-ring out of Ninja Flex that should help with the sealing of this connector here. Let's see if that fits. Alright, it fits. I'm just really bad at putting it on. Okay. Yeah, that's pretty good. Fortunately, it's not flat, but that should improve the water resistance a bit. Cool. So what do we have to do? We have to put the ZBMS into the battery box. We have to take a look at what I can do about the switch, because he wants the switch position to be inverted from the Fokker that is inverted from everything else. So push in for a latching switch, push in is on, and then stuck out is off. But he gets confused because it's different between his pint and the GT, so somehow I want to remedy that, and I think that's going to involve popping this out, which I don't know if that's going to be easy, because it looks like whoever put this together has just put so much silicone around. I'd have to dig it or get lucky somehow by just pushing, but I don't think that's going to happen since it's so flush back here. I can't get my finger or like a tool in there without probably damaging something, so that might have to just be that way. I'm not looking forward to that being the case. So it looks like there's I think he built electrical tape around it to give it just enough width. That is annoying. Maybe then I can take some pliers and dig away at that and get it out by like pulling it or something. That's pretty annoying. You can see right there, it's all like eaten up. And then what I assume is going to happen is if I can get this out and get enough clearance, he left the O-ring on it to pull it out from the outside. So got the O-ring there. I'm gonna have to save that, or not. It doesn't really matter. Man, this guy, I mean, he would have really benefited from a 3D printer. I'll tell you what. Get an Ender 3, and there's a learning curve, but you can get rolling in like a day. You'll print your first thing basically once you set it up. There's already like files that come with it. You can test it out, and it's like printing is such a it's like a freedom. Like you change your entire mindset when you have a 3D printer. If you're inclined to anyway, you can fix anything that has just been like, oh, it's just a stupid piece of plastic on this device or something. Might as well get a new device or deal with it. But no, it's like you can just, you just make it. That pulled the switch. Oh no. I might need to replace the switch now. That is some densely packed electrical tape. Look how those layers are stacked. It's like a topographical map. Oh, there it is. I win! Pull that out. So, from my observation, it seems that this has indeed been drilled to accept the larger switch. I'm assuming then that they use the same switch as the pints. That of which I have many, of just pint switches that I pulled out of boards so that I could cut them out, you know, bore out the hole and put a bigger switch. Alright, that is bored out, and that's nice. So where am I gonna find a switch? I don't know, good question. I do know I might have to save these. I have stuff in here. Do I have a switch in here? Plenty of pint switches. These should work with the U-boxes, right? I'm gonna have to update my VESC pint tutorial, because now they've got momentary switch support. So we could use the ones that we already have Alright, so this is a switch I got out of this is from the U-Box 80 volt. I think what I'll do is desolder it to save as much length from this cable as possible, because I'll probably use this in a different build. But that is what I have to do. Should fit right there. All fine. Minus the, I wonder if I could get that to work actually. Oh, I see. So he didn't actually get it all the way through. He didn't have the right drill bit. Understandable. I don't even have the right drill bit. It takes like a 3/8 inch, which is just a weird size, but I work at a really nice place that has nice drills. Do that just fine. So what I'll probably end up doing here is printing another one of those spacers. I think this will work with the pint ones, so I'll just whip one of those up. So just started that print. So I need to work on the next thing. I guess let's install the ZBMS. This beautiful, beautiful piece of work. It's a work of art. Hey, what is wrong with it? Hey, that's not screwed in all the way. Wait a minute, is that supposed to be like that? Shit, I guess it is. Huh, just bare threads. I guess that makes sense. I mean, you can't get the plate flat, but whatever. I'd expect, like, I don't know, spacers on that, but who knows. I noticed there's a thermal pad right there. Thermal pad, for what exactly? I don't know. I know that there's LEDs. I wonder, actually, I haven't asked him if all the power gets dissipated through the LEDs or if there are also drain resistors. Oh well, we'll find out. One thing I don't really like is are these wires. This whole situation over here is kind of, I don't like it. It's not what I would do. Don't really trust them. I don't know. They're flaky. This looks flaky. I don't like it. This is a bad install of a charge port, and especially you do not want charge ports to be wired that way, because that's what's going to be going on when you're sleeping overnight, when it's charging, when you plug your board in, you go to bed. This is going to be carrying 6 amps and it's flaky. That's unacceptable. No thank you. I'm going to get rid of that and your XT30. I don't like that at all. Okay, dude, just stop with the hot glue, man. You're making me second guess your motor. This right here makes me worry about the motor. The split there. Let me see how that is maybe not gonna work. Same with up here. We do not like corrosion on our connectors. Yep, there we go. You know, I completely forgot which one of these I need to hook to positive. I think it's one. One is positive, but I will base it off the charger. I trust no one. I will double check. What colors should I use for charger? Positive yellow, negative blue, green for ground. I don't know. And let's do orange. Orange and green. Those are charging colors. How long did I need that wire to be? Got these tinned. I'm gonna do the other side. Oh, look, see? I didn't even get that part. Huh. This is fine. I will fix that. Alright, first thing. Heat shrink. This is how you do heat shrink, by the way. You get the size that is just a little bit bigger than the wire. That's enough. And then you actually like heat the thing. It gets really small. You don't overheat it. I mean, that's not really a problem, but you see what happens when it shrinks? It shrinks in all directions. So now you have like these exposed pieces of wire. So you keep it hot, and then quickly you push that right up in there. Alright? Now when it cools, it's going to get hard, and all the leftover glue there is actually going to help me. But it's going to get hard and retain that shape. Now you've got a connector that will supposedly last longer. So on the other side, this is where I need to pay attention. So if I'm not mistaken, it should be that pin 1 is the positive side. Pin 2, or pin 4 is the negative, just because we're using the two closest to this little rotation thingy, but pin 1 is usually always positive, so I think that's a pretty safe bet. Let me apply heat shrink before all of this. So just gonna rest that there so that it kind of has a tendency to want to push down. So I've applied new solder, and I can fine adjust my position. And there we go. This already has quite a substantial amount of solder on it. So I'm just gonna go like this. Just gonna push it in. You can get away with a lighter. I just don't really like the burny part, and it's inaccurate, and it burns way hotter than what you really need, but that should be good. I see metal, but we're gonna be just fine. I don't know if the polarity's right. I'm gonna test it though. I'm gonna plug the charger in, make sure that this is getting a positive voltage, and it will be all set. 5 amp at 84 volt, has a big ass fan. Just hang it there. This is kind of sketch, honestly. See what happens. Ooh. Lights are on. It thinks it's charged because nothing is happening. Let's check on polarity, just to be extra sure. You can never be too safe. So, got my -1 attached to the negative. So this should give me a positive voltage readout. And it does, 84. No negative there. If I did it like this, it would be negative. That would be wrong. But we're good, so all good. So our charge port solution works, or you know, I rebuilt it right. And a lot cleaner, so you know, this cable run is perfectly even, wire length, easy to manage it, silicone wire, love silicone wire. I can just feed this back through here. I wonder, I bet he had them like this because the wire's stuck straight out, bent too much, and try to put it in. This looks like it'll actually work really well. So now we get, I guess we put this on, and it compresses it against a raised section. Very interesting solution. I wonder if this is stock. I don't think it is. I would not expect something that looks like this gear to be a stock solution. But I may be wrong because it is threaded. Like this section's threaded and this is a... How could you find a piece like this? It might be standard, I don't really know. I don't know what this is. Ah, shoot. It's spun wrong. Dang, it's really like butted right up against that plastic. I wonder if it's wise to continue threading it too much more. Really love it to just be like perfectly vertical, but I'm curious. I just got in a bunch of diodes. Should I incorporate a bunch of diodes? Because I would love it if I didn't have to you know, worry about the port being live and him potentially blowing up the BMS. Might be a good idea. It would be a good idea probably just to test it anyway. Let's see if the ZBMS, if it actually lets through reverse voltage. I'm not going to test it for reverse current. That basically just means sticking a fork in the charge port, but you know, I would like to know if voltage is present. I wonder which way it goes. Is this the same size? Can I potentially accidentally... Oh no, it's... Okay, let's do this port first. Should I? Fuck. I don't know. Is there a plugging sequence? Like an FMBMS? I think the goal was that was not something you had to do. That these should be mostly plug and play. I'm gonna go with the balance first. All balance are in. No fires. How about the battery? Will it be mad? So I don't expect anything to happen, of course, until I put voltage on the charger. Charge inside, anyway. I'm gonna route this in with the balance wires. Seems reasonable. I want to put foam here and here to keep the battery from slamming against that side. And then this can run along that. Will that meet? Oh, there is that interconnect part that I don't know where it is. It would be very unfortunate if I had to go Oh, this'll work. That's gonna work. Okay, so I can plug that in just fine. So I need to charge. We've already confirmed that the polarity is correct. We've got red going to the orange wire on the positive side, and I just multimetered that, so it's fine. The balance wires were made by Joe, so if it explodes, it's definitely Joe's fault. Oh, hey look, there's solder inside the battery case. That's great. Love that. I wonder how much more of that is in here. It's okay, I'll pop the battery out and we'll give it a nice pat on the back. Get rid of all the debris. So should we charge it? I want to make sure that when I'm messing with the battery that it is fully charged, as you do. That made my lights flicker. And initiate charging. Fucking Jesus Christ. It wasn't even on, man. So what that tells me is that yes, indeed, current goes back through the ZBMS, because what I'm assuming happened is these caps were not charged. The output capacitors are not charged on this, and so we just had a bunch of current go back through it. So we're gonna have to see if turning it on just ruins everything. I don't know if that blew something up, but I only heard a pop over here, so I'm assuming it's okay. Let's go. Oh, it is, the fan is spinning. We are charging. That's a good sign. Fortunately, I can't really monitor anything. I mean, the only thing that's going to end up happening is the ZBMS will start flaring up its lights. These guys back here when it's full and when it wants to start balancing. And I didn't take what the measured voltage was. We can find out though. We can find out if it's going to be anywhere close to that. We're at 76. That's, we've got a ways to go. Not dead, not full, kind of in the middle. So while that's happening, what do I need to do? I need to put more foam, consider adding diodes. I mean, what are we looking for current right now? Probably 5 amps as advertised, right? Zero that out. Doesn't matter if it's negative. Yeah, 4.5 amps. In my experience, in my system, I had one of these diodes in there that I thought would be enough for the main charger. I have a 6 amp charger, and it was getting hot, and I know if it was in an enclosed space, it would get way too hot. So unfortunately, with simple diodes like this, it's kind of a thing you need to consider. They will dissipate heat as they have a voltage drop. I've not tested these yet. They look pretty beefy. And I've used this style before. We can test that. If the test is successful, I think that would be very valuable. So let's stop charging. I'm gonna try. I'm thinking maybe the best option would be to put them here. The foam I know is gonna probably be bothered by the heat, so I can wrap it in Kapton tape, make a shield with fish paper, shield it from the battery, which also has shrink wrap and fish paper, with the diodes, but that'll allow me to kind of undo it if the diodes don't end up working for me. Oh, also, don't tell me that because there's a diode and there's a voltage drop that I'm not going to be able to fully charge my battery. That is not true at all. Ask me how I know. I just so happen to have diodes in my boards and they all fully charge. The voltage drop is there when there's current present that the diode has to pass. It's not magically stopping current from going through when it's, you know, one volt of difference or whatever. Once the battery becomes close to full, that current drops, which means the diode will have less of a voltage drop across it, and it will fully charge. If it doesn't fully charge, it's gonna be 83 volts instead of 84 volts. Big deal. Not a big deal. So these are, in theory, rated for 10 amps, but, you know, 10 amps with open air cooling. Will 2 of them make up for it? I have no idea. I've only put diodes in parallel like once before, and everyone says it's a bad idea, but that's okay. They can have unprotected charge ports. I don't really care. My charge port will be protected. This is the ideal diode. Here. Perfect. Just gonna make sure the polarity is correct. Shoot this way. Okay. For the test, I'll probably leave it just free floating here. No big deal. Plug that back in. Electrically, I've changed basically nothing. In terms of like, you know, it's not, haven't changed polarity. Should be all good. And remember, turn this guy on first. There we go. Okay, so it's gonna start heating up like crazy now. It is definitely heating up. Will it get unhappy? I'm not really sure. I can use this piece of foam to kind of gauge how hot it actually is. Turn off this fan here too. I want an ideal inside battery box experience for this diode. As representative as possible. The wires are starting to get warm. This might not work. Yeah, the wire is actually heating up a lot. Holy shit, this must be roasting. Whew. Yeah, might not be a thing that I can do. Not safely anyway. They need a heat sink. That's kind of the problem. Can I smell that? They're certainly unhappy, I'll tell you that. But will they burn through that foam? I don't know. It's weird because, you know, components can get hot, but hot for components is a lot hotter than what my fingers can safely touch. But I also have to be aware that the hotter the component gets, the more convection's going on around it, which wouldn't be as good inside of a battery box, or, well, present at all, really, because it would be completely enclosed, and, oh, yikes. Okay, that is starting to melt through that, isn't it? Press it in, see what happens. Leave a mark? Yeah. So it's dropping voltage through it. That's not great. It's starting to melt through that. Okay. This is conclusive. I know if it was one diode, it would be extremely unhappy, but it makes me worried. I definitely don't want things getting hot in the battery box. So unfortunately, this needs to be kind of... You should really only use this configuration in like maybe systems under 3 amps. Maybe under a certain voltage too, because I think that affects it. I think that affects the heat probably because of the voltage drop characteristic. But you definitely want probably an ideal diode of some kind. We really need a diode that works at our operating voltage, because there's ideal diodes out there, but they're all really, or well, in the short time I've been researching, they're all really low voltage. And by low I mean like 30 volts, definitely not 100. We could get one like that uses a MOSFET instead and actually protects against like shorts on the outside and stuff like that. Maybe it could have anti-spark for ZBMSs. That would be pretty nice. But until then, he's gonna have to use a charge port cover or something, because yeah, diode is not the solution for packs like this where you can shove 6 amps into it. So that's I think that's kind of a done deal there, isn't it? We've installed the ZBMS, rewired this guy. Everything here looks great. Looking for my tweezers. Where are my tweezers? Just gonna pick this little speck out. Make sure that the battery pack is nice and clean, preferably free of dirt. I need to fill quite the space over here. But I mean, this is pretty solid. I really like the GT battery box. It's quite spacious. You put a lot of batteries in there. Definitely like at least a 19S battery in the 21700 format being able to fit its way into here. I think that's realistic, right? Mitigate movement over here, and then I should double it up over here. Yep, that's pretty good. Probably want to do something about the ZBMS floating around. It is very convenient that the connector ends there. It would be cool if the lights were visible. I kind of want that. Maybe the solution is put more foam here. The ZBMS is pretty light, so I'm not really too concerned with like what holds it down. Should be able to just have the balance connection serve a lot of the... I do double-sided tape. I have some nice double-sided tape. I could just do a strip and a strip, or well, one strip. I think that's a good solution. Ah, these scissors are garbage. So just put it right. I like it. the challenge of taking the other side of the tape off. Please. Man, look at my tweezers again. Right in front of my face somewhere. I know they are. What? Oh, they're under my hand. You know, this stuff's almost like not sticky. Oh my god. Wow. Get off. This was the worst idea. It doesn't stick to this material at all. Go. Okay, we'll just put it there. Call it a day. Yep, that is going to exist there. Hopefully that will withstand the test of time. Looks good to me. I mean, that's fine. Put a piece of foam. Even if it bounces around, it has a shield around it, so that's fine. It won't wear out like the pint VMS's. I trust that Joe made a great battery that will not suffer from that problem. Now I have to figure out how this split O-ring works. Now does this shake around? It still does. Wow. We need thicker foam. I have more foam in the car, but let's just put one of the red ones there. Stack it. It'll provide a hybrid solution. Yeah, that's more solid. Now, the most important screws exist here. This is where most of the water is going to get on the board, is in this back section. So it's very important that you keep both. If you're missing screws, keep these 4 at least. So here's the switch port, or the switch riser thingamabob. Looks like it fits in there like in the pint, I think. Maybe once there's a switch inside. I know this is definitely fitted for the pint, so I'm making a wild guess that this is gonna work. See, if he drilled it correctly, if he drilled it all the way through, it would be much more snug. But in this case, it kind of looks like it needs more, which is kind of annoying. Yeah, I don't know, I guess I should print a bigger one. I don't really want to drill because I could hit the Fokker. So I'm gonna go design a new one. Okay, that is now printing. I think the switching portion is the middle pin, and then either normally closed or normally open. The Fokker, if this is the off position, the Fokker will be wired this way. If it's wired this way, then you turn it on by having it out. Push in for it to be off. So I'm gonna solder on this pin that hasn't been soldered to before, because the U-box is wired differently. And wire to this. Positive here. I want to power the Fokker. Not with the battery yet though. I have this. The wrong connector. Get a different plug. Well, I know what I can do. Let's plug this in. Minimize everything on this because I know it was charging batteries with it earlier, so it's on by default because that's how a Fokker works. Even though, oh, what is that? You upset? But why? Get over it. Is the LED not working? Might. Oh. Okay, on. Hooray! The switch works. But the LEDs aren't working. Oh, this is like coming out. What the? Do it again. No? Did I get the pin out wrong? Huh. There's also no idle drain. I kind of thought there would be idle drain. Pulling 2.6 watts. Just sitting there. Really curious. Whoa. It's sensitive. Why? Let's try testing some of these pinouts because I'm probably either reverse polarity or something's happening. I'm not sure. Is this not green? Getting red. There's red, but no green. Bring it up a little bit. 3.7 volts. It makes reds shine pretty good. How do you make green go? Like this? Oh, I completely guessed. Interesting. Why would it be like that. That's really strange. Is there another secret to making red go? Look at that proud green switch. Love it. Big fan of that. Switch. When it's not on, there's no drain. There's probably a tiny bit, but turn it on. Starts off a little bit, then it boots up. Starts taking a lot. Almost 3 watts. It's kind of a lot, but it is casting Bluetooth and running a software and stuff, so I'm not completely surprised at that. A quick update. We just stopped charging. The ZBMS is quite lit up. I'm assuming that means, well, I know that means it's balancing cells, but unless it charged, maybe it charged up to 4.2 and then it's bleeding it. I'm not sure. We'll have to see.